Hello everybody, today we're going to be doing about exponential and logarithmic functions. First, let's start with exponential functions. Let's start with the basic exponential function, y equals a to the power x. X is the exponent and a is the base. Let's start with the example y equals 2 to the power x. Now, if you plot the graph, this is the 5 data points. Now, if you plot the graph, you can see that this is how the graph will look like. From this graph of y equals 2 to the power x, it can be seen that when a is greater than 1, the graph increases like that. Alright, so this is called an exponential growth. Now let's try when a is less than 1. So when the basic one is y equals a to the power x. So let's take the example y equals half to the power of x. So this is the graph points, the 5 ones again. And then now if you see, the graph is going like this when it's y equals half to the power x. So from this graph of y equals half to the power x, it can be seen when a is less than 1 but a still has to be greater than 0. The graph is decreasing like that. So this is called an exponential decay. Thank you, and now we'll move on to logarithmic functions. Move on to the basic logarithmic function. This is the basic function y equals log ax. This is an example we're going to look at. Y equals log 5x. So now this is the graph. So if you plot the graph, this is how the graph will look. It will increase like that. From this graph of y equals log 5x, it can be seen that when a is greater than 1, the graph will increase and it will intersect the point 1, 0. Now we're going to take a look at the function when a is less than 1. So this is the basic logarithmic function, and then now we're going to look at an example of y equals log 1/5 x. So now we have plotted the points again, and the graph now, instead of increasing, it has decreased slowly. From this graph of y equals log 5, it can be seen that when a is less than 1, but a still has to be greater than 0, the graph will decrease and yet it will still intersect the point 1, 0. Next, we'll look at the relationship between an exponential graph and a logarithmic graph. Now we'll look at the relationship between exponential and logarithmic graphs. Take y equals e to the power x to be the exponential graph, and y equals ln x to be the logarithmic graph. Now, this is the graphical approach to the relationship between y equals ln x and y equals e to the power x. So, as you can see, here is y equals e to the power x, and here is y equals ln x. Now, if you look closely, you would realize that this is actually a reflection over the graph y equals to x. Alright, this can be proven through the algebraic way. If you put y equals ln x and you take the equation y equals x, and if you do substitution, you'll find that actually it's equals to y equals to e to the power x. This applies it for also the y equals to e to the power x. When you substitute y equals x into the equation, you'll realize that you're equal to y equals ln x. From this, it proves that these two graphs reflect over y equals x to become the other one.